Let's look at the law of sines. I want to define the law of sines as well as show how to use it. Let's start with a triangle, and we're going to call the vertices A, B, and C. And when we talk about A, B, and C, we're talking about the angle at that particular vertex. The sides opposite an angle, we use lowercase letters to denote that. So this is side A, at the bottom is side B, and to the left is side C. And the law of sines is a way to relate the angles in the sides. The law of sines says the length of side A divided by sine of angle A is equal to the length of side B divided by sine of angle B, which is equal to the length of side C divided by sine of angle C. So it's a way to relate the lengths of the sides and the sine of the angle. Let's look at some examples of how this is used. Let's look at this triangle here where I have two angles and a side. This is called an SAA triangle because I have a side, an adjacent angle, and then the next angle as I move around. And I want to be able to solve this triangle, meaning I want to know all of the angles and all of the sides. Let's start with angle C. We know that the angles of a triangle have to add up to be 180 degrees. So that tells me 42 degrees plus 59 degrees plus C is equal to 180 degrees. If I add these up, I get 101 degrees plus C is equal to 180 degrees. And then I can subtract 101 degrees from both sides to get that C is equal to 79 degrees. So I have found my first piece of information. I found this angle. So now I have all three angles. Next, I want to look at side B. I know angle A and I know side A. So the law of sines tells me that side A divided by sine of angle A, which is 42 degrees, is equal to the length of side B divided by sine of 59 degrees. We can cross multiply so that this is 37 times sine of 59 degrees is equal to B times sine of 42 degrees. Using a calculator, we get that this is 31.72 is equal to 0.67b. We can then divide both sides by 0.67. And when we do, we get that 47.40, once we round to two decimals, is equal to b. So side length b is 47.4 centimeters. So we can go ahead and fill in that information. Finally, let's find side length C. So once again, my law of sine says that side A over sine of angle A is equal to side C, which we're missing, over sine of angle C, which is 79 degrees. Cross multiplying this way, I have 37 sine of 79 degrees. In this way, I have C times sine of 42 degrees. 37 times sine of 79. If we use a calculator, we get this to be 36.32. Sine of 42 degrees is 0.67. So we have 0.67c. And then we can divide both sides by 0.67 to get that side length C is 54.28 centimeters. So we've now solved this triangle since we have all three angles and all three of my sides. Here I have another triangle. This is known as an ASA triangle. Just like the previous triangle, I have two angles and one side, but this one's different because the side is between the two angles, whereas the other one was a side that was not between the two angles. The easiest thing to start with is angle B. We know that angle A plus angle B plus angle C is equal to 180. This tells me that 85 degrees plus B is equal to 180 degrees. And if we subtract 85 from both sides, I get that B is equal to 95 degrees. So this picture is definitely not drawn to scale. This angle here should be 95 degrees. Next, let's start using my law of sines to find A and C. I know that side A over sine of angle A is equal to side B, which is 21, over sine of angle B, which is 95. So this is A times sine of 95 degrees when I cross multiply. And this direction is 21 times sine of 50 degrees. Sine of 95 degrees is 0.996, so this side is 0.996a. 21 times sine of 50 degrees is 16.087. I can then divide both sides by 0.996 to get that side A is length 16.15. So now I have all three angles and two of my three sides of my triangle. Let's find our last side, side C. We know that C over sine of angle C should be equal to the length of side B over sine of angle B. Cross multiplying, this is C times sine of 95 degrees is equal to 21 times sine of 35 degrees. Working this out gets me 0.996C on the left, and on the right, 12.045. We can then divide both sides by 0.996 to get that the length of C is 12.09. So if I change the length of C in my picture, I've now solved this triangle. I have all three angles and all three sides.